So we are now live on YouTube, and very good morning to all of you. You are all welcome. And as you know, today's session is cluster 1, session code 01A. And in this session, we will discuss about the low cost experiments and what is the importance of this low cost experiment in schools as well as in all stratas of our education system, from beginning from secondary school to senior secondary, higher secondary, UG and PG, in all over there is a great importance of this low cost experiment when we are talking about science teaching and learning. And we will discuss on it. We will discuss on the different design and designing aspects of the low cost experiments and all other technical commodities. So, and that will be discussed or mentored by Dr. Subhash Chandra Samanta. So right now I am handing over the session to Dr. Subhash Chandra Samanta. So sir, please, this is over to you.
Thank you, Anirban. And I also offer good morning to everybody. Now, it would be good if we introduce ourselves. Is it not, Anirban? Should
Yes,
we
sir.
start?
Yes, sir. Sure.
Should we start the introduction? I myself is Subhash Chandra Samanto. I was a physics teacher at Midnapur College, and I was also associated with Indian Association of Physics Teachers. In fact, sometimes I was its general secretary, and even now I am on its EC. And in fact, that gave us that my association with Midnapur College and IFET gave me enough opportunity to explore many ideas related to low-cost experiments and project works. So please, each of you introduce yourself. Let us start.
Myself, Subroto Chandra, assistant teacher, physics, Domdom Airport High School. Thank you.
Thank you. Next.
Sir, I want to say another thing, that after introducing yourself, everybody, I would like to request, please put your mic off then, because otherwise the noise will come again and again. So that's my request. So please carry on. I would like to request the next one to introduce.
Hello, sir.
Yes.
Hello.
Please, madam.
This is Malarvidi from Tamil Nadu.
Okay.
Coimbatore district, may all know. I'm an assistant professor in the Department of Chemistry.
Okay. Welcome,
in the Department
madam.
of Chemistry. Thank you. Thank you.
Thank you. Okay, next, please do it very rather in haste so that we do not lose much time.
Good morning, sir. This is Debmallo Sen from Kolkata. I am teaching in Bhavanipur Gujarati Education Society School up to class 10, physics and maths.
Okay, thank you. Welcome to this program. Next, please.
Hello, sir. This is Atanu Ghosh from Paschim Bardhaman. Hello, am I audible?
Yes.
Hello, sir. This is Atanu Ghosh from Purva Bardhaman.
Achha.
Working in Kanduria High School. I'm a doctorate in zoology.
Welcome to this program. Thank you.
Sir.
Next.
Hello, I'm Renalini Deshmukh from Reliance Foundation School, Lodhivli in Maharashtra. I'm teaching 10th, 11th, 12th physics. Thank you.
Welcome, madam, to this workshop. Thank you. Next.
Hello, good morning. Good morning, sir.
Yes, please.
I'm Ranjit Kumar from Jammu, and I
Okay.
work at Government High School, Hathel. There I teach class 10 students.
Welcome.
Thank you,
You are
sir.
very much welcome to this program. Thank you. Please,
Thank you,
next.
sir.
Good morning, sir. Me Ajitabo Ghosh from Bisnupur High School, Department of Physics.
Okay, thank you. Next.
Good morning, sir. This is Rikshika Savri. I'm from Patna Women's College, and I teach there as a guest faculty, and I'm doing my PhD from NIT Patna.
Okay, Rikshika, for joining the program. Thank you. Anybody from your side?
Hello.
Hello.
Morning to everybody. Myself, Prosenjit Das, and also the B.Ed College lecturer and member of CIRE, Center for Interdisciplinary Research and Education, Jadavpur, and also member of Human Rights. Thank you.
Okay, welcome to this program. Thank you. Next. Is introduction complete or anybody else there?
No, I think there's some others like Raghavalli. I'm not good. Can you hear me, Mr. Raghavalli? Mr. Raghavalli, can you hear me? Okay, I think there would be some issues, maybe some issues with his system or anything.
Should we start the program?
Yeah, I think we should start.
Okay. I'm just starting the sharing of the screen for my talk.
Sir, I have a question.
Yes, please.
Sir, recently from different news channel and media, to come to know that there is risks from using Zoom. Is it true, or how it is? Can we use Zoom app during online classes with our students in school?
Actually,
sir, may I?
the way we are using it with password protection is not bad.
Sir, may I?
Yes, you please.
Actually, you have already know that that the Home Ministry has issued some norms to use the Zoom. Actually, there is no platform which is 100% proof. So there are always loopholes in everywhere. So we have to maintain the proper sanctity and security, and we are using this platform, maintaining all the securities that have been mentioned by the Home Ministry. And you can see that we are using the waiting room. Actually, if you want to maintain it properly, you have to activate the waiting room. You have to disable the permission to join before host. You have to you don't share your ID and passwords to others. So that's why you have already noticed that we have shared the ID and password in encrypted email, so that you even cannot copy, paste, forward, and print the mail also. So we are taking all of the security measures that are needed and recommended by the ministry, and as of our own knowledge and experience. So I think there would be no issues with the Zoom app in our classroom. And if you want to use it in your classroom, so that I would like to request, please maintain those securities that I have mentioned. issued and mentioned by the Home Ministry. And right now, Zoom is also working with the ministry to develop more security patches. Zoom have already provided lots of security patches, so I think there would not be any problem till date. And we didn't get any problem till date that we have already run some of the previous pages and also. So I would like to request you that if you want to use this platform, do it with maintaining all the proper securities. That's it.
Thank you, sir.
Okay, sir, this is Atanu Ghosh. I want to say something that as you have mentioned that we can't copy the password and ID that you have sent via the mail. But today only I have started this app only through the copying password ID from the mail and pasting in the Zoom. So I don't know how it is being done actually.
So have you seen that your ID and password was encrypted?
That was encrypted, but I was able to copy that.
You are getting that just because of when you are trying to join from that mail to the Zoom. And if you will notice that the forward and other options are blocked in that mail, and that security also is provided by Gmail own system.
Okay. Thank you.
Good morning, everyone, all the teachers. I'm very sorry for interrupting. I'm just joined and I missed that introduction session. Myself, Shankhu Chakraborty from DAV Public School, Midnapur, and I'm teaching the biology for classes 10 to 12. Very sorry for interrupting.
Thank you, Shankhu. Professor Samanto, can we carry on?
Should we start? Yes, I have already shared the screen. Do you see all these things?
Yes, sir.
Do you see the screen?
Yes,
Everybody?
sir. Yes.
Okay. Then you see the title of my talk is Conceptualization, Realization, and Examples of Low-Cost Science Experiments. Okay. So actually, why low-cost experiments? Low-cost experiment means that whatever things available in my neighborhood, in my home, in my college, we can do some experiments which may be meaningful not only for the school students, even it may be meaningful to the students at the higher levels of learning. And in fact, I have started this journey of rather designing low-cost experiments as early as in 1987-8, when I was just experiencing of conducting project experience for the BSc third year physics maths classes. You see, before that, our college was affiliated to Calcutta University, and around that time, its affiliation changed from Calcutta University to Vidyasagar University. And in Vidyasagar University, there is a provision in the syllabus that all the final year students of BSc physics honors should have to do one project experiments. Basically, with the teachers, even with the teachers did not have any idea how to conduct a project experiments at the BSc level. So we really resented that this type of program, particularly in the realm of experimental physics, was really very difficult. As a PhD scholar, we did some project, of course, but that was in the realm of theoretical physics, mathematical physics, not in the realm of experimental physics. So we are really in a very bad position at that time. But because it was included in the syllabus of Vidyasagar University, we are bound to do it. So we actually then thought, why we can't do it? As for an example, sometimes I thought that how can we measure the optical properties of some liquids? And then it came to mind that we can prepare one prism, hollow prism, where liquid can be taken and that the liquid prism can be placed in the spectrometer, and all the experiments with which our students are even well exposed can do. In fact, when I told this idea to my students, they readily, next day, some of them readily prepared one hollow prism, just going to the photography shops, and we started the work. And we really did very beautiful works, you see. Some of the work is such that one student actually studying the variation of refractive index with water, determine what is the electric dipole moment of water molecules. And it was really fantastic. It was very low cost experiments, means in fact we didn't use nothing. And with that thing we got the result, which was not exact result of course, but we found the order of magnitudes. So the journey started in that way. So in explaining these things, how the experiments have been normally designed, how they have been realized in practice, we are taking some examples, one from physics and another from biology, botany in fact. Actually, because these two experiments are landmark experiments for me, actually, in fact, the first experiment is that even the class 7 students know that a hot iron piece fails to attract significantly the magnets. Why? Because its magnetic property actually decreases with the rise of temperature. So with that thing in mind, that physics concept in mind, I had an interest to develop an experiment to find the Curie temperature. Okay. I wanted to develop an experiment on Curie temperature. You see, but point is that I knew it very well that iron had a Curie temperature of the order of 760 or 80, perhaps 80 degrees centigrade. And in our lab that time, we did not have a provision of getting that high temperature. So it's next to impossible. Then I was searching for materials which can have low Curie temperature. And some of my students suggested that ferrite rod, which are used in antenna of the that time radio, so that can be used because they suggested it's ferrite. Its Curie temperature is somewhat less. Somewhat less. It may be around 250 degrees centigrade. So I thought that it's better to prepare a transformer with the ferrite rod as its core, and we did it. And you know, a transformer has two coils. One is called the primary coil, and another coil is the secondary coil. And the ferrite rod is its core. That's the three elements. The core, which is actually cylindrical ferrite rod, and the primary coil, primary coil and the secondary coil. Our students did all these things, and we got an AC set, that is another transformer, ordinary transformer that we are used to do in many experiments. So that transformer has been taken as the source, and that is connected to the primary, and you see the secondary is connected to an AC voltmeter. At the room temperature, we have seen that much induced voltage is there because it is actually acting as a step-down transformer, because primary has got some higher numbers of winding than the secondary coils, and we got that induced electric. In fact, that can be used for explaining the electromagnetic induction. So if we like to do that thing for the school students. Now what happened, you see, when I put the transformer in a hot sand bath, actually we took sand in an aluminum pot, and sand in, and the transformer, the prepared transformer is put inside the sand, and everything, the total system is put over an electrical oven, heater, in fact, electrical heater. So as the system is connected, that is the primary coil is connected to the AC source. It is giving some voltage to the, and the primary is actually having some current, and the secondary is connected to an AC volt. At the room temperature, we got a sizable voltage, say at the order of 10 volt, like that. But as the temperature rises, we have seen that secondary voltage in the secondary coil, as measured from the AC voltmeter there, is continually decreasing. And after some time, the voltage is as low as 5% of the initial voltage at room temperature. So as we know that with the that transfer has got a ferrite rod has an important property, that permeability, and actually with change of temperature, this permeability, rise of temperature, the permeability is decreasing, and it has got the tremendous effect on the induced voltage. So when the voltage is say 5% of its initial value, then it is clear that the ferrite rod has got the Curie temperature. So I found the temperature, measured the temperature at that time, it was almost 250 degrees centigrade, and that was the temperature quoted in the text. So that was the first experiment on Curie temperature that we have done. Afterwards, that time I was associated with IIPT, and IIPT was organizing physics Olympiad experiments, our Olympiad programs, and for selection process, there was an experimental examination with a question paper, experimental-based question paper, and I was asked to give one experiment. I did this experiment. It was highly accepted, appreciated. But afterwards, I did not stop here. That is, I'm telling how things continually unfolded. You see, because you see, it happened. You see, in the year of say 2002 or like that. You see, that time we are organizing one program. In fact, in this day we are also organizing that program. It is called Professor C.K. Mujumdar Summer Workshop in Experimental Physics. Only the outgoing third-year students were rather participating in this experiment. So the experiment was held sometimes, I think, Belur Vidya Mandir like that, and program was held in that. And best students in and around Calcutta College did participate. And one of young professors from Beshu, now this is called IIEST. So he just observed the observation, experimentation of the ferrite rod by the students, and he took the data simply, that the secondary voltage and the temperature data. And without doing anything, without doing any experiment, he obtained the second order phase transition curve, which is a very important experiment in statistical physics. It was a very good experiment that time, because you see, we did the experiment, but we took the data, but we did not analyze it, because I did not have that theoretical idea to transform this experiment into a second order phase transition in statistical physics. So in the next time, in that university, in that time it was called Beshu, and they actually included this experiment in their PG for their PG students. And afterwards, this experiment was included in a few universities, Calcutta University, so many universities are there. So you see, we started an experiment to demonstrate the heating effect on magnetic materials, ions, for class 7 or secondary students. And we ended up with an experiment which is actually suitable for the postgraduate students who are actually reading statistical physics. So I just am telling this journey, and this is one experiment that I'm telling. And second story is related to photosynthesis. You see, just 1 year back, actually we submitted a project. We have got one science club here, Science Center Mindapur, and on behalf of Science Center Mindapur, we are actually submitting a project proposal for low-cost experiments, and to the central government, DST, Department of Science and Technology, and they invited us to rather defend our project there. I went, along with one of my students, went to Chandigarh for the purpose. And that time, that student, he was also a physics student. They actually developed photosynthesis experiments out of practically nothing. Because sometimes we feel that when you go to schools for such experiments, they complain, no, we don't have beaker, we don't have funnel of that size, we don't have hydrilla, in so many things. Hydrilla is commonly available in the rural areas. At least the people who are concerned with photosynthesis experiment, they know it, where it's available. So, but it was really difficult to find the beakers, large beakers or large funnels. So he had that idea, that just cut a 1.5 cold drink bottle into two halves. The lower half is considered as the beaker, and the upper half is transformed into a funnel, and it worked very well. So we showed that experiment where we are going to defend our project proposal. And it was readily accepted when they showed that the huge amount of oxygen is coming. And they told us, the people who actually were who sat in the interview table, so that is it working so well? If it is working so well, then is it possible to prepare commercially oxygen from that that system? I was told that I have not examined that thing, maybe or may not be. So they readily accepted our proposal, that I'm thinking, project proposal. So these are the two things I'm telling, that project low-cost experiments does not mean that they are meant only for the qualitative experiments, meant for the secondary school students. It is not that. We have done many, many such experiments which are actually done. In fact, it is well done by the higher secondary and the PhD students, even postgraduate students also. That means when you are doing an experiment for the BSc or postgraduate students, then you have to have some quantitative measurements, because without quantitative measurements, you cannot verify certain principles, certain laws, and you can measure something which is relevant. So low-cost experiments can be endowed with the practice of measurement that we have done. So all the experiments that we are used to do should have some component of measurements. And in fact, I believe that without doing measurement, without taking data, without relating the data with the mathematical structure of the model, we cannot do science positively. Yes, we are used to do some low-cost experiments at the quality. That is good, because you see, with that thing, we can attract our students to the experiments. But if we really want to verify certain concepts, then we have to take the measurements. Again, one thing is that in this low-cost experiment, sometimes in this low-cost experiments, many concepts are intermingled. And if you can't rather isolate the concepts, then you cannot rather help the students to learn effective concepts, in individual physical concepts or scientific concepts from the experiments. So that is why, even when you are doing some low-cost experiments, you have to take it in mind that when you are going to show it, demonstrate it, that you have to isolate the different concepts involved in it, associated with it. And that can be done only when you are rather taking some data and you are analyzing this data. So this is my preliminary observations, preliminary statements, that how we can conceptualize, how we can design a project, a low-cost experiment, and how can we realize it. So we did this. We have got a lot of experiments in our tables, and we can share their ideas. So, and if it is possible, because you see, right now I am going to describe some experiments, low-cost experiments, of course, which you can do even when you are sitting at your home. That is because all we are rather contacting through this digital platform. So when we are suggesting that you have to do some low-cost experiments, then it is apparent that you have to do the experiments right now when you are sitting at your home. In fact, some of the students at that secondary classes at class 7 and 8, they are also asked, how can you use my time with doing such experiments? Then I actually suggest, and they are doing the experiments. Okay, so this is the my preliminary observation. Now I come to the experiments. Okay. In the meantime, if you have anything to say, you may make comments. Perhaps it has become a monologue, so it's better if you get some issues to interact with me from my talk. right now.
So we would like to welcome our participants to interact with Professor Shamanto, because we always need a both side interaction, otherwise it cannot be made fruitful. And in the meantime, Professor CK Ghosh also joined us. So uh, I would like to request Professor CK Ghosh if he has something to say.
Professor Ghosh? Hello, Professor Ghosh?
Yes, good morning.
Good morning. Have you heard what I have talked?
No, actually, I was a little off during the initial stages. That's why I joined hardly 2-3 minutes back.
Achha. I actually talked of two experiments. One is actually related to second order phase transition in statistical physics, which has been developed out of project works, or low cost experiments starting from class 7 to rather MSc students. Ultimately, this experiment has been included in a few universities in West Bengal as their routine experiments in statistical physics. Because this experiment is very, very low cost, and every university has the ability to rather prepare this set for their own students. So that I have told how the experiments have been designed while I was talking with the class 7 students on the heating effect of magnet or magnetic materials. From that, we have actually generated an experiment where the object was the ferrite rod. Ferrite rod was actually used as a core in the transformer, and everything is heated in an oven or used sandbar. Temperature is measured, and it is found that when the primary coil is connected with the AC source, the secondary coil gives some induced voltage certainly, as it is a step-down transformer. And ultimately, when the temperature of the system is raised to Curie temperature, practically there is no induced voltage in the secondary, across the secondary. So we are rather confirmed that the temperature is the Curie temperature. That was around 250 degrees centigrade, and actually that tallied with the values given in the text. Next, in the next experiment was actually developed by, next part was developed by Minhaj, you see, and Minhaj version of Beshu. He did nothing. He did not do the experiment, only took the data from our CKM workshop students, you see, and from that data, he just constructed that lambda transition. You see that beautiful experiment. So, but point was that we did not publish, neither me nor Minhaj published these experiments. So, but now you have no scope of publication because they are now included in the university syllabus. So that is the one experiment that I have just told before the participants. And next experiment I told about the photosynthesis. This experiment is very simple, photosynthesis, because whenever we want to do photosynthesis experiments, we need at least a big beaker and a big funnel. And in most of the school where we went for ATLP programs, you see, on behalf of IIT TLC, and they did not provide us. So some of our students thought it's good. Let us have the beaker and that funnel both, but just cutting a 1.5 cold drink bottle, and that was fine. That was working very well. So Professor Ghosh, I have talked up to this point. Okay.
Now, what is the further agenda for today?
So,
sir, today's actually, I wanted to tell some stories how the low cost experiments have been conceptualized and realized, and now I shall give some examples. That example is actually concerned with the present situation as we are in the lockdown period. So we think that our participants, if they can share our views, they will be able to do these experiments even while sitting in their rooms, in their homes. Okay, so that is my side. So I am going to tell about some things. Perhaps I actually in the last phase also I have talked some experiments. Of course, this time I am doing some new experiments also.
Sir, I would like to mention that our focus is on, I would like to mention to Professor Ghosh that our focus in this session will be on what is the importance of low-cost experiment, how can we use these experiments in from secondary level to PG level everywhere, because we have some UG and PG professors here also, so they may be interested how they can use in their part also, and the designing aspects and designing part of the experiment. And then and finally I will discuss about the technical things, that how we can use this Zoom to show such experiments live to our students, what will be the technical accommodations, and these are the main things we will going to focus. So I would like to request you if you have something to say about this.
In fact, thank you, Anirban and Professor Shamanto, in fact, for giving me the cue. Professor Shamanto is the ideal person to talk about it because he has created a very effective infrastructure at his Science and Culture Center in Midnapur College, and where there has been a setup of lot many inexpensive experiments, and virtually, why should I say low cost, even some of them are no cost experiments. Now the idea is to give a message to the teachers that, well, we often complain about lack of infrastructure, but whatever infrastructure is available has to be utilized fruitfully for the benefit of the learners. And that is where this low cost experiment, we don't need very sophisticated instruments to bring home a principle of physics or to bring home an idea of physics. And that is the message which we want to convey. And the other thing is that about experimenting altogether, I would like to say, and I'd like to share this with the fellow participants, that normally when we interact with students, there are many good students I've interacted with, and their focus is theoretical physics, or they would be able to name some teachers who have taught them physics, but the theory part of it. They don't have a role model for experimental physics. Like Professor Shamanto is a role model for the students of Midnapur College, or in fact the entire student community, which spreads over a wide range of ages, right, from very junior students to very senior students. The entire student community considers him as a role model for experimenting. So am I audible?
Yes.
Am I audible?
Yes,
Yes,
sir.
yes.
So I'd also like the students of these days, and particularly the students whom you would be meeting after doing this program, they would consider you role models for experiments. That is extremely essential, and they should know how to perform experiment, the ethics about doing experiment, the maintenance of honesty while doing experiment. This is very much required of the student for performing experiments. And if a student can devise his or her own apparatus, then he or she will feel proud of it and will be able to perform experiments with that. Like explaining certain standard phenomena. Normally when I ask students, of course the very beginners, say one who has just heard about vector quantities, will say that a vector quantity has magnitude and direction. And then if I follow it up with the question that is current a vector quantity, now they get confused because they have heard that current has got some kind of direction, and they may say come out with the idea that current is a vector quantity. And as we all know that in proper parlance, current density is a vector quantity, and the surface integral of current density constitutes whatever current we get in an electric circuit. Now, the word direction in the definition of vector quantity refers to a straight line. It means that a vector quantity essentially acts along a straight line. When we say that electric current has direction, the connotation of direction is not the same as that when we tell it in the definition of a vector quantity. A vector quantity has direction means a vector quantity acts along a straight line. Now, you ask the student to look at the strap of his bag, which he carries to the school. Now, the strap remains under tension when it is in his or her shoulder. And the geometry of the strap is exactly a straight line, which indicates the direction in which the tension vector in the strap is acting. When we are playing carom and we have spread French chalk on the carom board, that's a normal practice so that the striker moves smoothly. And we drive the striker or we hit a particular coin, and we can see the track the track gets drawn through the French chalk, and that is a straight line, which shows that momentum gets transferred along a straight line. These are of course demonstrations, not experiments. But what I wanted to say that with whatever available equipment you have, with whatever available devices or this, for whatever experiment, whatever examples I cited for that, you didn't have to purchase any new thing, but you can very well demonstrate that a vector quantity acts along a straight line. Ask them to follow the cover drive played by Virat Kohli. The ball travels all along a straight line. So you can drive home the concept of a vector quantity. And the other aspect which occurs to me is about measurement. Now, there is a kind of reluctance in the students in general about measurement. So what is the length of this room? What is the length of how many centimeters is my pen? So these are sort of questions which at times make the student uncomfortable. So they have to understand the role of measurement, the importance of measurement, and you'll have to think. In fact, Professor Samanto and myself, we have experiments through which measurements have to be done, and from which several important concepts can be brought home. So these are certain initial observations which I wanted to make, and in fact, the success of this low-cost experiment, particularly the one on statistical mechanics, and its graduation into the syllabus of post-graduation or undergraduation, is a remarkable success story. And I'm sure that the teachers who are participating in today's program or will be participating in this series of programs will have several such other success stories to share with us, and will also be able to perform experiments with inexpensive devices and make them popular. I wish you all the best. Over to Anirban.
So I would like to add few points actually to just to clarify it to our audience. And as we have lots of participants from different subjects, so that I want to mention, please don't think that we are discussing on physics. Actually, we are trying to discuss and put some example before you how to design a low cost experiment and what is the importance of low cost experiment. As we know, from different parts of the India, the basic problem remains same in our schools and even the colleges and universities. Always we face some issues with the infrastructure. We complain that we don't have this, we don't have that, but that cannot be the impediment in front of us when we are teaching science. So actually we have developed lots of experiments, lots of experiments on physics, on chemistry, on biology. But here we have some constraint like time constraint, we have some constraint like due to the lockdown. So we cannot show everything to you right now. So we can put some physical example in front of you, and that will be given by Professor Samanto, and Professor Samanto arrange whatever he has in his room, in his house. So with that, he will put some example. You can take it just as an example, then think on your own part how to design, how you can design that. Suppose Professor Samantal already talked about the experiment with photosynthesis that I want to mention, the photosynthesis experiment. And there is also experiments with the respiration in biology. We always say that in our laboratory, in school laboratory, we don't have respiroscope, we don't have large 500 ml beakers and so on. So we thought how to overcome that. So Professor Samant already told that we started with an idea that we take 1.5 liter of cold drink bottle and cut it on its upper part. So you can assume that the lower part would act as a beaker and the upper part would act as the funnel. So we made it and did the experiment, and the result was quite good, and even similar to that result we found in our laboratory, well-equipped laboratories. In case of respiroscope, suppose we don't have respiroscope, what can we do? So in that case, we use some bottles. Actually, we have to understand what are the basic requirement, and then we have to figure out how this requirement can be fulfilled with the low cost materials or no cost materials. Then we have to design the part, and we have, during the design, we have to consider what error can what error can come in front of us, what error can disturb this experiment. We have to assume that how we could take the data from it. So these are the part that we should consider during the experiment design. So that is the thing I want to convey. And in the meantime, I'm getting in chat that lots of the participants want to convey some words from their end. So I would like to request them, please, if you have anything to say, please say on mic, because we cannot attend the chat every time when the session is going on. So please, I would like to request you, please say if you have something to say on mic. Someone, I just had a glimpse that someone is telling that she had a problem with the transformer, and Mr. Odelu Kumar was trying to saying something. So I would like to request you, please say on mic. That will be easier to handle for us. So please. I think Miss Nehal conveyed something. Please, Miss Snehal, if you have something to say, please say on mic.
Hello, everyone. First of all, I would like to thank Professor Samanta for his wonderful experiences with low-cost instrumentation. And I feel that low-cost instrumentation or the experiments are very good tools for a teacher. Because whenever you are explaining something, my subject is also physics. So in physics, we have a lot of abstract concepts, and it becomes very difficult if you are not able to show something. Then for the student side also, it becomes very difficult for them to imagine and experiment, imagine the things and have the feeling of those concepts. So low cost experiments are very, very easy tool for that. And also, as you can, as the sir was also saying, that it's from very small things you can prepare such experiments. So my question is to Professor Samanta, that when we want to design some low cost experiment, on some particular phenomena, for example, surface tension, if we want to explain that particular phenomena, what should be the method in which we should go, what steps we should take, because every time you cannot have the insight about all the things in one go. So what should be the steps that we should follow if we want to design some low cost experiment for some particular phenomena? Thank you.
Well, I shall discuss these things when in an appropriate time, okay? I shall be discussing one experiment related to the flow of water, okay? That time I shall discuss it.
Okay, sir. Thank you, sir.
And I think I would like to mention Professor Samanta that during his discussion, he may talk about our experiment with Cartesian Diver, because I am
Yes,
mentioning
I have got two things in
because
mind.
that is
That
the
you just
experiment. Yes, sir.
You just remind me that time. Okay.
Yeah, because with that experiment, we can explain lots of things in a single experiment. So that is the important of that. And Mr. Odelu Kumar was trying to say something. So Mr. Kumar, can you please say on mic?
Hello? Hello?
Yes.
Sir, good
Yes, sir.
morning, sir.
Good morning.
Sir, we want to talking in the rural area, sir.
Yeah.
Sir, we want to about optics chapter, sir. Low cost experiment. Sir.
Low cost?
No cost. Optics.
Yes,
Optics.
yes.
Optics
I have
experiment.
got many experiments. Of course, this time, because you see, optics experiment needs some things that not that you cannot get these things. Okay, I shall discuss this thing as you are telling.
More one electromagnetism and electricity, sir.
Actually, as because we are in rather lockdown period, I have that you are not getting anything. So I have designed my talk in that way, so that whatever things available at your home, you can use for doing some experiments. So that is why I have not rather touched that electromagnetic experiment or optic experiment. That can be done in course of time. Here I can do, of course, no problem. I can do. Today I cannot.
And I think Professor Samanto can share the ideas to you.
Yes. I shall tell.
And Anirban Gupta is raising hand, so please tell whatever you want to say.
Good morning, sir. I am Anirban Gupta from Silvassa, Dadra Nagar Haveli. I wish to ask one question. When we are designing low-cost experiments, how important is it to have error determination? And naturally, if we are having designing something from like scrap or something, like sir gave an example about the bottle and cutting it to form a beaker and funnel. So definitely there would be some errors which would be incurred during the experimentation process. So how important is it? How important is error determination while designing low-cost experiments?
Your audibility was not good. If you repeat the question, then it will be good for me.
Am I audible, sir, now?
Not that much. You can just raise your voice sometimes.
Hello, am I audible, sir?
Now audible, but if you raise your voice, if you speak loudly.
Okay. Sir, I wish to know, while we design low-cost experiments, maybe some experiments that we design from scrap, there ought to be some errors which are incurred during the process. So how important is error determination in low-cost experimentation?
Okay, I shall discuss these things right now when we are discussing the low-cost things. As for an example, you see, I have told you. This time, let me continue, okay?
Yes.
And in the process, I think I shall answer your question.
Okay, sir. Thank you. Yes,
okay.
Sir.
So should I continue my talk?
Sir, actually, Devmallo Sen is raising hand. I think he have some question.
Okay.
So Devmallo Sen, please.
Good morning, sir. Debmallo.
Yes.
During this lockdown period, we are compelled to take online classes. And I completely agree with this. When we demonstrate something, it is much more easier for us to communicate with the children. I was working on this and I have just recorded 1-2 video on experiment. And when we was teaching them, I find it was very nice to them. So I am looking for more and more ideas. So during this period, how we can just make the student more comfortable and easily they can get the concept. Thank you, sir.
Number one, you can share your ideas with us. Number one. Number two, I can give, in fact, in this small period of time, I have given just 2 hours. It will be completed on 12 o'clock. So in that way, I cannot discuss all the things. Number one, number two, because you see that I also do not have all the things at my disposal. But still, if you like, I can discuss about. Someone has told about optics experience. I can tell just using a filament lamp. Using a filament lamp with the filament as its source, we can do a lot of experiments involving reflection, reflection, and dispersion. All the things can be done. Whatever included in the higher secondary syllabus, all the experiments can be done. Of course, you have to have the optical elements, lenses, mirrors, prisms, and so many things. But as a source, if you have to use only the filament bulb, a 60-watt filament bulb, nothing more than that. And if you have got the other optical elements at your disposal, you can do all the experiments up to class A higher secondary standards. Okay?
Yes, sir. Thank you. Sir, just give us the idea when the lockdown is over.
Okay. Then I shall show these experiments. Simply show 1 and 2, that will be sufficient. Okay.
Okay, sir. Please continue.
First experiment that can be done by everybody. that is a simple pendulum experiment. I think you are you seeing the screen? Is it visible?
Yes, sir. Clearly.
Visible. And you can get a 2-3 meter long always thin cotton thread, and you can get a small cheap stone and suspend it. Either if you are rather having a courtyard, you can suspend it from the branch of a tree, or if you are a roof from the ceiling. So it will be 2-3 meter long, and the stone chief weighing say that 50 gram or more, less than that, will be acting as the bob. And you can do and explain all the things. You can explain terms such as bob, tension, linear amplitude, angular amplitude, restoring force, potential energy, kinetic energy, use of properties of circle to find the relation between amplitude and energy of the pendulum, principle of conservation of energy, decay of amplitude and energy, time period, determination of G, verification of the law of length, law of amplitude, law of G also, length of second pendulum, linearization of a parabolic graph, log graph, estimation of error, etc. In fact, with these single experiments, if you allow to admit, I did at least 2-3 hours for doing all these experiments. We can do all the things. Someone has told that how can we estimate the error? If you estimate the error in these simple experiments, you will see that whatever error you are getting in your lab experiments with simple pendulum, the error will be less than that here, because you are taking a long pendulum. So time period will be rather more accurate than what you are usually obtaining in your lab situation, your school lab situation. Number one. Number two, what can we do? You see, we can find whether the time period depends on amplitude or not. We can find what is meant by the angle in radian. What is the relation between the amplitude and the length of the pendulum? Length of the pendulum, the amplitude. We can do many things. How normally if we plot time period versus length, the graph will be parabolic graph. How can we linearize it? We can linearize in two processes. Either you can draw a graph between square of the time period and amplitude, or you can take the log and log graph. In both the cases, you will get linear straight lines. You can determine G. Even in the log graph, you can find the exponent of the relation, T equal to twice square root of L by G. So if T varies as L to the power half, you can see that this is really half from this experiment. You can find G also. So many things can be done. You can explain so many concepts, the tension, the restoring force, etc. So I think only you have to just do the experiments. Not only that, you can tell each and every of your student to do the experiments and learn from these concepts. Even there is another, this experiment is actually usually lab experiments, that measurement of time period. And there is another experiment, the variation of the amplitude with time period, the exponential, that can also be done with this simple experiment. Okay. So, and suppose there are two pendulums. I am now continuing some experience with pendulums only. Two pendulums are there. Yeah, you see, these two pendulums are side by side as they move and something. Yes, here these two pendulums are actually suspended from the same rod. This rod is a robust rod, so that when one pendulum is allowed to vibrate, the rod is not vibrating. That means the energy is not transferred. But if you rather excite them together, so that initially they are in phase, because the time period is different, because the lengths are different. So you will see that though initially they are in phase, afterwards they will be out of phase. But sometimes, after some time, they will be again in phase. And from that concept, you can find the difference in length between the two. You see here, actually, the length difference is very large. But actually, in a problem, that was actually a problem for the physics Olympiad experimental problem, that suppose you are given two pendulums. One is, say, of length 200 centimeter, another of 201 centimeter, and you are given nothing. You are given nothing. Only you are allowed to touch the system. You have to find the ratio of the lengths of the two simple pendulums, because then you have to know what is meant by phase. So this is one experiment. You can do it at your home. You can tell your students to do it at home. And again, you see the same two pendulums, but they are now suspended from a rod again, but that rod is again suspended. So if I oscillate, if I excite one to oscillate, one of them, then actually energy will be communicated to the other. energy will be communicated to the other pendulum. So initially, suppose my left hand pendulum is excited and right hand pendulum is at rest. Then what will happen? Perhaps you have all done this experiment. What we will see that right hand pendulum, which was initially at rest, starts oscillating, starts gaining amplitude. And when the second pendulum, the right hand pendulum gets maximum amplitude, maximum displacement, then actually the left hand pendulum stops. That means it has transferred its whole energy to the second pendulum. But when this time is reached, you see the reverse is happening. That means the right hand pendulum starts losing amplitude, whereas the left hand pendulum gains the energy. And this transfer of energy will take place continually, but not all the time to come, because you see that air damping is there, and very soon both the amplitudes will be decayed. So naturally, but sometimes you can see that, in fact, we call this as the mechanical beat. We have seen what is meant by optical beat, and now you may call it a mechanical beat. And using these two beats, actually, you see, there are 3 time periods: the time period of the left pendulum, time period of the second pendulum, and it appears that they are exactly equal. Is it not that? Because even you see that you cannot make, so long there is energy transfer, the time periods are really different. So you can, because 2 pendulums having same length cannot transfer energy in between. So you'll find that there are 3 periods: TM period of the first pendulum, T1 period of the second pendulum, T2, and the period of energy transfer. So these 3 periods are related. You can ask your students to find what's the relation between the 3 periods. If they can understand what is meant by the audio beat with 2 frequencies, they are usually doing some sums on it, they can find this also. So these are simple experiments, and because you see that it is experiment, but results will not be that good because system is not that robust. So I'm going to the next experiment. Yes. You see, when we are defining a simple pendulum, we have told that the thread should be very thin. It should not have any mass. But if you have a massive pendulum in a massive thread in a simple pendulum, that is a rod. We have taken a rod. Rod, of course, is a thin rod, but it's a metal rod. And if we do the experiments, then we can do all the experiments with a simple pendulum. But when you take a rod, then it is not a simple pendulum. By definition, it is a compound pendulum. Okay. So you will find that time period is not twice pi to square root of L by G, as it is true for a compound pendulum, but time period is T equal to twice pi to square root of 2L by 3G. Again, you see it is independent of mass. Okay. So but you can find the time period also, you find the G also, and you can do all the experiments as you are doing with a simple pendulum. This is also very good, like a simple pendulum. Only thing is that time period is not twice pi to square root of L by G, but time period is twice pi to square root of 2L by G. Okay. So again, you can study the amplitude decay, which is exponential function with time, with this experiment also. So these are some experiments which can be done by your students who are at miles of kilometers of distance apart from you. You can just give them that task, they will do it. Another simple experiment, you see, this is actually basically a biology experiment, botany experiment. Studying botany, they are used to do experiments with leaves. You see, that leaves that you see do not have any specific geometry. So the students are asked, undergraduate students in botany are asked to find the area of a leaf using graph paper. I think this experiment is actually related this problem. Students, I have inquired, none of them are doing this experiment, but they're supposed to do the in mathematics or in physics. It is included both mathematics and physics also. So if one counting the numbers of small squares within the circumference of the circle, within the circle, inside the circle, and the number of small squares through which the circumference passes, one can find the area. And you see here the accuracy of the result depends when the number of, when the area of the squares is very small. If you take it millimeter, your result is good. If you take it 5 millimeter, it is not that good. So necessarily it depends on the result, depends on the size of the square you have taken from the graph paper. So I suggest that you can ask your students to find the area from the graph paper, as well as by calculating, as well as they can find the value from calculation using the formula pi r square, or in fact they can see whether these two are equals or not. And in fact they can find also, if they can find the area from the graph paper, they can divide the area by square of the radius and find the pi. This is another method of drawing a value, getting pi. Okay. So that is that you can also tell your students from distance, do the experiments and tell the result. Actually, but I have got a defined purpose of doing this experiment. You see, I do not know, as someone was telling the errors in measurements, you see. So what is the error in measuring the radius, area of leaf using this graph paper? Certainly, I have told you that if the squares, small squares we are using have really very small area, millimeter size or less than millimeter, but with less than millimeter it is difficult to count. So believe me, up to millimeter we can count effectively. So the error is in that case less, but still we want to quantify. How can you quantify? Actually, we started this experiment just to quantify the errors in measuring the area of leaf. You see, that suppose we have got found the area of the circle from the graph paper, and we know if we assume the value of pi to be true, 3.14 or like that, then we can find the area from calculation also. Then we know that the difference is like this. These two results will not coincide, so you can find the error in measuring, because I assume that that analytical method, that is using the formula, we are getting the correct result. So I am not bothering about the measurement in the radius accurately or not. But suppose we are getting the accurate result, then necessarily this statistical method using graph paper, I think it's rather some erroneous. It is some error. Some error should be there, and that error we can quantify just taking the difference. So when we are measuring the same area, suppose we are measuring the area of a leaf having the same area as that of circle, then we can quantify that how much error is actually incorporated because of the graphical measurement. In that way, we can rather find the error in the graph paper also, in the leaf measurement of leaf also. So we see that in that way, we can quantify the error normally done by the BSc students in botany in finding the area of a problem. That is because I have designed the entire talk based on the information, whatever available in the home when we are sitting. We are using the glass, you see, for drinking glass. And you know, it is not of uniform cross section. The open mouth cross section is larger than the bottom cross section. Suppose open cross section is radius r and the lower cross section is the radius smaller, and the perpendicular distance between the two planes is just L. From these three measurements, the radius of the open mouth, radius of the bottom surface, and the distance between the two centers of the two circles, we can find the volume of the this truncated cone. It is, I think your students know what is meant by truncated cone, but they can verify that thing. And how can they verify? They can take some water within it, and water can be measured using, you see, measuring cylinder now at this time is not available at home. So they can use one rather, you see, cough syrup bottle, 100 milliliter or like that measuring. So that can be used to measure. In fact, some measuring rather pots are also there, very small pots are there, cylinders are there, that can also be used. So they can measure even they can measure the value of pi also using this experiment. Yes, most important measurement that can be undertaken and very much needed is the measurement of mass using a first class lever. Actually, we designed this experiment based on the concept what is called lever principle. You see, lever principle has been formulated centuries back. Not, in fact, it has been afterwards explained as the principle of equal moment, as the principle of equal moment. But before that, it has been explained that the product of the effort arm and the effort is equal to the product of the load arm and the load. So this is actually anything you have in your room that is a small length. In fact, if even a scale of 15 centimeter, 30 centimeter can do. You can use a 30 centimeter scale as the scale, as the lever rod, and as the CG, you can, through the CG, you can actually suspend it using a thread, and two masses are small m and capital M are suspended. You can compare their values. So using this whenever you have got, and of course one mass m, one mass should have a standard value. It is not absolutely needed. If you want to specific gravity or verify Archimedes principle, then it is not needed that you have to have one standard value. But still, you can consider one of them as the standard value, and you can compare, and you can find, you can verify Archimedes principle, determination of densities, relative densities, and so many things. And if you really want to have a standard weight, then you can take one, you see, polythene bag, small polythene bag, thin polythene bag, and put 100 milliliter of water from a cough syrup bottle. That will act as a 100-gram weight. And you can do all the experiments absolutely correctly. And I'm again telling you, some people are telling that whether they are accurate or not. I am telling it is really very accurate, because if you, while you are doing this experiment, if you just if you move the load slightly left or right, you will see the balance is seriously disturbed. Even the fraction of a millimeter, if you displace the loads through a fraction of a millimeter, then the weights are very disturbed. So I think errors are very small, at least the errors with which we are associated. And again, I see that we have got some problem with the errors, but you see, when we are doing an experiment at the secondary level, high secondary level, then our errors are not that much rather to concerned with. Okay, we can ignore those errors even. But suppose if you use this rather device, this is that we call it a scale balance, and then you will find, and I find that the density of chips, of stones, and so many things, or suppose kerosene, you will find that standard results are not much different from the results you are obtaining. So you are sure that accuracy is not that much hampered here. You are getting the same accuracy, what is needed almost at this level of learning. Okay. So I am going to next experiment. Yes. At home, you have got another one wooden plank or plank of fiber or anything you like. This what is shown in the picture. And suppose the plank PQ is the first, it is at the on the surface floor, and keeping Q point fixed, you are just moving the P point upwards, and there is a block, wooden block. I think wooden block you can get, or you can a stone chip with plain surface, and you will see that a certain angle Z, the block, that wooden block resting on the plank, just starts sliding. So naturally, then this angle Z is called the angle of repose, and tan Z, that is actually H by L, is the measure of frictional coefficient. So that's a very simple experiment. You can measure the frictional coefficient. Okay, your students will do happily these things. Sorry. Determination of dynamic friction. The block is the same thing, and now the angle is slightly greater than Z, and the block starts moving down. And naturally, the acceleration, it is just a textbook experiment from class 11 physics books. You find acceleration G equal to sin Z minus N is the friction, N cos Z. So you can find the acceleration, and you can verify the laws. So, and you can estimate the dynamic friction also, and you will find the dynamic friction is always less than the static friction. So this is, I am really going fast. If you tell that I am going fast, then I can rather I can become slow somewhat. If you have object. If you object that I am too fast, then you can tell me. So this plank is as the wooden plank or the fiber plank of fiber is set in that way, and that a ping pong ball or a spherical marble is thrown just upward direction. Then we'll see that if you have one mark on the plank X, say, then this this spherical ball will cross the cross the cross twice. One during its upward journey, another during its upward journey. So, in fact, if the time period times of crossings are P and Q, then we can construct a quadratic equation out of the equation S equal to UT minus half AT square, and we can find that as we can find the time very conveniently. We can find that P plus Q equal to twice U, twice U by L. Sorry, there is one mistake. Twice U by capital L, where U is the initial velocity, and product of that times P and Q, the solutions of the quadratic equation is 2L by A, where A is the acceleration. So this is very simple. We can measure A, and from that measurement again we can find the frictional coefficient. But here it is the rolling friction, and rolling friction we have seen is very in this it can be ignored. This measurement can be used to determine estimate G also. I have told that G estimate of G, not measurement, because you see error will be much there.
Sir, I'm interrupting once. Actually, two participants has two questions that they have said in chat box.
Okay, let them talk.
I would like to mention Mrinalini Deshmukh, who said something regarding while assembling transformer.
Anirban, can you be a little louder? I'm not getting you.
Okay, so is it okay, sir? Right now?
Yes, we are having.
Okay.
Now it is okay.
Mrinalini Deshmukh wrote that while assembling transformer have faced problems. Can I get information on gauge of wear to be used, number of turns minimum needed, and how to decide I by P primary AC voltage as faced problem of heating and short circuiting? That was her concern, and Mr. Orelu Kumar wrote something regarding, I think he had a confusion regarding the pi concept using the graph paper and the real pi mathematical value. So I think he had such some confusion regarding that. Actually, from his writing. Yes, sir. Please tell me.
Okay, I am coming one by one. Okay, first Madam Binali Deshmukh. Actually, I have told that we have prepared the transformer using the ferrite rod. First, you have to collect the ferrite rod. Number one. Number two, you have to the ferrite rod. One thing is that with ferrite is actually non-conducting, so there is no problem getting conducted. So if you and the wires we are getting, they're actually they're painted, so that they're insulated wires, copper wires. Okay, and you can get, you see, 25 gauge.
Just a minute, Mr. Kumar, please mute your mic.
The number of turns should be, I think, in the okay. Hello, should I continue? Is it audible to all of you?
Yes, sir.
You have to win the number of turns you see for primary coil. Say you are winning 500 turn, and for the secondary coil you may win say 100 turn. And when you are connecting primary coil, another transformer that is actually you have to buy from the market, it will cost not more than 100 rupee. And in that case, for safety, you have to connect one because you see the output voltage for that transformer should not be more than 10 volt, 9 volt in fact, it should be. Okay, so you can connect 9 volt directly. If the number of turns is 500 and the gauge is 24, then I think it will not cause any damage. Okay, And second, in the secondary, it's fine. You have to connect one AC voltmeter. On the digital voltmeters, digital meters have got AC voltage measurement provisions also. You can use that thing. I think you have got your answer. Is it, madam? Hello.
Thank you, sir. I got my answer. Thank you, sir.
Okay. Thank you.
I'll try.
And what's the other problem? I could not understand what you are telling. Oh, yes, you are telling that whether this pi is theoretical or mathematical. That I don't know. I don't understand this difference between the theoretical value
No,
of pi
no,
and
no, 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 no. Actually, I think he want to ask regarding the value, assessing the value using the graph paper and the real value.
No, actually, in that case, it's real value. It depends on. I have told when I was just talking. I told that it depends on the. It depends how accurate will be the value of pi on the using of the minimum smallest graph. Sorry, smallest square in the graph paper. Suppose we are giving a millimeter graph paper. There are provisions. You can use the millimeter squares, that is squares whose sides are 1 millimeter. You can use the squares whose sides are 5 millimeters. You can use the squares of 10 millimeters. And you will daily see that when the errors will be different. Errors will be different. Okay? You will get that when the accurate value will be for that counting when you are counting actually the number of smallest squares, that is 1 millimeter, because you don't have the squares with sides less than 1 millimeter. Okay, but if you count the squares with sides 5 millimeter, naturally error will be much, and with 10 millimeter it will be much higher. I think you have got your answers. Is it not?
Okay, Demal Shen is raising hand.
Yes.
Sir, I have a doubt in the force vibration. The definition is given. Force vibration is that when a body is vibrating under the influence of a external force. My question, when the body is vibrating under the external force, the frequency and amplitude is depending on the external force, or it is independent?
You see, you are actually vibrating with certain periodic source, is it not? It has got a definite frequency, forcing frequency, okay? And another is the system which is actually impressed with that that periodic force has got its natural frequency. So actually there are two frequencies, minimum at least. The periodic frequency of the periodic force which are actually impressed to cause the vibration of the body, and the body has its own natural frequency. It may be more than one frequency. Okay. So now you tell what is your problem.
Now, Professor Samanto, he was asking about amplitude and frequency. I think amplitude definitely depends on the amplitude of the force vibration.
Certainly. Now, then you answered the question, sir. Okay. Hello, Professor Ghosh.
Now, I think his question was about amplitude and frequency.
Whether the amplitude depends on frequency or not. Whether the amplitude depends on frequency or not, that is the question.
No, sir. My question is the amplitude and frequency are related anywhere to the external periodic force which is applied.
No, certainly, because amplitude depends on the amplitude of the external periodic force. Certainly, it depends. The amplitude of the induced vibration depends both on the amplitude of the periodic force. It depends on the frequency of the periodic force. As again, at the same time, depends on the frequency. On its natural frequency.
Sir, I don't get it. Natural frequency and external force frequency will depend on each other, or it will go independently?
No. Because you see, frequency will not be dependent. Frequencies are independent. You see, but I am telling that amplitude of the induced vibration should depend on the amplitude of the periodic force. Is it not? And amplitude of the the amplitude of the amplitude will depend certainly on the periodic frequency, frequency of the force as well as the frequency of the body which is undergoing vibration. I think these are actually very nominal questions. If you go through the any textbooks on oscillation and vibration, you find this answer. At least I know up to that point.
Sir, when I was doing the experiment, I find that sometimes the amplitude shoot out and sometimes is very less when it is touching the vibrating external.
Please tell me the experiment which you are doing.
Sir,
Please tell me the
I have taken a
experiment.
scale, stick to it and made it vibrate. And I put a simple pendulum over the here. So the scale is hitting the pendulum and it is make it vibrate. So sometimes I found that it is shooting out and sometimes it is just touching and stopping like that. So there is no total pattern of the vibration.
Will you please, we shall be having other sessions also. I think if you demonstrate that thing, it will be fine. Huh? We shall discuss the things in details, okay? Or if you write just a few lines, I shall understand at that time we shall discuss it again, okay?
And I would like to request Professor Ghosh, if you could, if you have something to say, please proceed. Professor Ghosh, can you hear me?
Am I audible now?
Yes.
Right. This simple pendulum experiment about which Professor Samanto has mentioned has lot many possibilities. Last time we discussed the drawing of the log T versus log L graph. That is, the student for himself is trying to find out the nature of variation of T with L. That is, he's trying to find out the power, and this log graphs will be a straight line, and so from the slope of the straight line the law of variation can be determined. So this is one experiment which I'd like to suggest. In fact,
no, Professor Ghosh.
Additional read.
Professor Ghosh, do you hear me? Mr. Bernoulli has asked one problem. I'll ask a question. If you rather listen to his problem, I think it will be good. He's telling that when he is doing an experiment on force vibration, he is getting some unexpected results. And please, Mr. Sen, please repeat what I have told you. Hello.
Yes, sir.
Please, Professor Ghosh may help you this time. Okay. Otherwise, if you discuss the things in a session, details, then we can. Okay. Now you continue. Mr.
Sir, I was taking a scale one end in the gap of two wood, and I tried to vibrate the scale. The top part of scale was vibrating. Now, when I is holding a simple pendulum with a small marble, I find that sometimes when it is hitting the scale, vibrating scale, sometimes it is shooting out, and sometimes it is not getting that great amplitude, or sometimes it just gets stopped. This is due to the phase difference they are hitting, or anything else, and I don't have any idea that.
That is, I'm telling. I will have to see the experiment. It's better. Okay. Otherwise,
I'm not getting the setup. Can you kindly repeat?
That is.
Sir, if we put a scale, metal scale, one side fixed, and if
it is clamped, a scale is clamped. Okay.
Yes, sir. One side clamped.
Horizontally.
Yes, sir. No, sir. Vertically.
Vertically clamped. Okay.
If
and nearby a pendulum is oscillating.
A pendulum is just kept in the contact with the scale from the top end. Now I pull and release the top end, it will vibrate.
Okay, which one? The pendulum will vibrate.
Sir, the scale, I'm pulling.
That's a scale. Oh.
And I release it, so it will do this SHM.
That means both the pendulum and the scale are vibrating.
Yes, sir. When the scale hit the pendulum, both are starting vibrating.
Yes. Then I think the phase matching is a problem.
Okay, sir. Okay, sir.
Because the scale will be a compound pendulum in this case, isn't it? If I have understood you correctly.
Actually, Professor Ghosh, what he is telling, it is actually clamped scale, and clamped scale means you see that it is almost a cantilever type system. It is vibrating in that way. Of course, it is vertical, and the vibration is horizontal. What I have understood from his statement.
Yes, sir.
The vibration takes place in a vertical plane.
Vertically, the vertical plane, but it is oscillating in the horizontal line. Okay.
Right.
And when you see in the nearby there is a simple pendulum, it is also perhaps oscillating the same line. Sometimes it is in contact with the free end of the scale. Sometimes it is not, and it may happen that both the when they are in the phase, perfect phase matching, then it's shooting, amplitude of the pendulum is shooting. If there is no perfect matching, then it's not to shoot. That depends on the situation. And I think it is completely driven by the phase situation.
Because Mr. Shen, please see that the phases of the pendulum and the scale which you are using, so they are continually changing with time. So there will be instances when the phases match, and in that case the amplitude will shoot up. Otherwise it will not shoot up, because in all cases of force vibration the amplitude is generally weak. But in such cases when there is a phase match, then this thing can happen.
Yes, sir.
The other thing which I want to suggest, last time also I suggested an experiment. If a long pendulum can be suspended from the top of these days we have multi-storied buildings, or say at least from the 4th floor or 5th floor, with a big rope, and if you hang a little heavy stone or something like that at the bottom, which plays the role of the bob of the pendulum, and it is made to oscillate, and ask the student to move with the pendulum. Now in that case, since the student will have to move, he will physically feel the change of acceleration, because otherwise he normally sees motions under uniform acceleration, say motion of a free fall, which is under uniform acceleration. Or what he is going to determine with the help of a simple pendulum experiment is the value of acceleration due to gravity, which again is considered to be uniform. But if he runs with the pendulum, then he will see that the acceleration gradually decreases as it comes towards the mean position, and the acceleration again increases, which is when it's moved away from the mean position. And so he will have to adjust his physical motion, and so you will have a physical feel of what is happening in the case of oscillation. So this is one experiment I'm going to suggest. And then maybe an experiment for the law of isochronicity, that is, you take bobs of different shapes, different masses, and try and see whether whether there is any variation in the time period or not. And the fourth thing will be this about this myth which comes through several textbooks, that in case of a simple pendulum, keep theta within 4 degrees. That is, I say, is a myth, because theta has to be small, and the oscillation of a simple pendulum is approximately simple harmonic, and the approximation is nearer to reality as theta goes nearer to 0. So as theta tends towards 0, the oscillation tends to become more and more simple harmonic. And we can make a very simple calculation by way of which you can feel that the approximation which is required in the theory for establishing t is equal to 2 pi root over L by G is sin theta equal to theta. Now we can do just orally. If theta is equal to 30 degree, that is pi by 6. So pi is 3.142 divided by 6. So in the first place of decimal, it would be 0.5. And sine 30 degree is also 0.5. It is also equal to half. So up to first place of decimal, they're equal up to theta equal to 30 degree. Students know the value of sine 18 degree. 18 degree is a convenient one because 18 is pi by 10. And so that is 0.3142. And if you calculate the value of sine 18 degree, which can be done from the laws of submultiple angles in trigonometry, and it comes to be root 5 minus 1 by 4. So root 5 is equal to 2.236 minus 1 is 1.236, and that divided 4 is 0.309, which is roughly equal to 0.31. So here you see up to second place of decimal they are matching if theta is equal to 18 degree. So more as you move towards 0 degree, there would be match between sine theta and theta. This is what I have said theoretically, but this can be experimented so that this gets impregnated in the mind of the student. So these are some experiments which came to my mind. If something occurs, I'll the scale balance experiment also, lot many things are appearing to me, but I think let us again go over to Professor Shamunto, because he might be having so many other things to share with us. Professor Shamunto.
Okay, thank you.
Sir, I don't know about your detailed planning. So just I want to ask, do you have any preparation to show any live experiments today?
No, live experiments. No, I have no. I shall show some video at least.
Okay.
Okay.
Actually, I think in first phase, Professor Samanto showed some live experiments that so that can be done in any days afterwards.
Yes, that I shall show certainly.
Yeah, and
Today
with that,
I want to give an overview how low-cost experiments can be conceptualized, realized, and there are some examples are there. Because initially I had got that presumption that it is better to give some inputs that can be used for, as someone was telling, so that people can tell their students to do the experiments in that. As per the graph paper experiments, that's the angle of repose experiment. The simple explanation. This can be just if the teachers tell their students about phone that do the experiments in that way. They can do and learn a lot. That was my objective for this block. But if they want to see, suppose so far that simple pendulum experiment is concerned, that is not much to be shown. Yes, everyone can feel it. Again, what Mr. Sen told me, I think that experiment is fine. We can see that really fine experiment. In fact, I shall try to afterwards. I shall try to if he can show it, no problem. Otherwise, we shall try to do this experiment. Okay. So because you see, some people have told that how can you do some optics experiment? That I'm telling. Next, I'm going to some optics experiment that can be done in this lockdown period right now. Okay. I'm moving on to the next period. Actually, this is a problem you see with two mirrors. The two mirrors are making an angle 50 degree, and we have got to say a small pencil 2-3 centimeter long. If it is placed on the bisector of the angle, then you can find the images are 6 images are seen. Clearly, you can see 6. But if this pencil, small pencil here, is just pushed sideways to one of the mirrors, then you will find 7 images. So that is a very good thing. And you can tell your students to do the experiments at home, because everyone can find 2 mirrors, no problem, at their home. If it is broken, it will help much more. So this is the next experiment is again on optics. Yes. Now on the terrace, you can hold a vertical stick of no length A in a sunny day and measure the length of X of its shadow on the terrace. Repeating the experiment quickly with 2 more sticks, one can find the elevation of sun at the time of experimentation. Is it not? Suppose if see the angle theta, you will find that if we do the experiment, 3 experiments we are telling with 3 sticks, the sticks have to be held vertically on the terrace, on the surface, and the shadow, we can construct this vertical triangle XYZ. Okay, we can construct the vertical. We can construct another triangle ABC with different sides of the sticks and shadows. In fact, we can see that we can show them how they're related. That is the heights of the heights of the sticks are proportional to the length of the shadows. If we observe the things at almost at a particular instant of time, that is suppose we do the experiment at 10 o'clock, then we have to do complete the experiment within 10 plus minus 5 minutes. Then we can see that it's almost constant, and tan theta equal to x by y z, we can find the angle of elevation of the sun at that point of time. Again, if they are not introduced trigonometry that time, they can be rather introduce geometry also. This is tan theta. They can find and similar triangles properties. With that means a lot of mathematics, geometry can be done. Properties of similar triangles, trigonometry, many things can be done. Not only that, they
I think Dr. Samanto has got disconnected. Can you hear my voice?
I think for a few seconds it was disconnected. Should I repeat what I have done?
Yes, yes, sir.
Okay, actually, I was talking of an experiment meant for verifying the principle of rectilinear propagation of light. All you know that in homogeneous medium, light travels in rectilinear paths. So here is a stick XY. Here is a stick XY placed vertically on a surface terrace where enough sun is there. So, and you will find that shadow is YZ. So we can measure the length of the stick XY and its shadow YZ. Similarly, we can take other two sticks of length, different lengths, and measure the corresponding side. We'll find this triangle XYZ. If the light which actually comes from the sun reaches the point X, actually goes through Z in the straight line path. If it does not go to the straight line path, it may bend. Then naturally you cannot draw the straight like that rectangle. Sorry, that right angle triangle XYZ. You cannot right angle triangle XYZ because the XZ is a straight line. The path of the light is XZ is a straight line. Okay, in homogeneous medium. So we have got actually 3 right angles, and we have measured the heights of the sticks and their shadows, and the ratios will find always tan theta. So we can explain what is maybe tan theta. We can explain what is we can talk about the verification of the principal rectilinear propagation of light, because you cannot draw that triangle if light does not travel in straight line paths. You can tell about their tan theta definition, and again you can, and all these things are possible. That is xy by yz equal to tan theta, or ab by bc equal to tan theta is possible only these vertical triangles are similar triangles. You can tell them about the properties of similar triangles. Okay, so we are, because you see, when we are doing geometrical optics, practically we are doing a lot of mathematics, a lot of geometry, even sometimes calculus also. So my next experiment again is on light. It is our common observation. Suppose there is an empty tank in the courtyard, your courtyard. When it is, you have observed it. When it is filled with water, you will see that bottom is off. Bottom has been raised. So that means that due to refraction, as it is shown in the figure, that due to refraction, the object at the bottom has been raised to some extent. So we can find the depth of the image from the free surface of the water, and depth of the object as well as the depth of the image from the free surface of the water. And if the depth of the object is u and that of image is v, we can see that u by v is the reflectivity of water. In fact, you know that as Professor Ghosh was telling, that when pendulum angle is very small, angular is very small, that is it is closer to sin theta equal to theta. So practically we have to use these things also here to verify that refractive index equal to u by v. Again, here is my one of my suggestions is here is that if you like or not that you see, we can, because you see reflection of light, we are teaching the students at the 7 or 8. But that time they don't know what is rather trigonometry. They don't know sin R. But sometimes we are talking, even in some books, there are sin I by sin R equal to mu. These statements are there, Snell's or statements is there. But I think they are not understanding these things because they have not been yet introduced the trigonometry that time. So is it not possible? We can define the refractive index as the ratio of the real height, real depth of the object and the apparent height, apparent distance. I think we can redefine the refractive index at that way. Now again, I'm telling you how we have done the measurement, because you see, when we are measuring the, we have taken a cylindrical glass of uniform cross section, and a coin is placed at the point at the bottom, at the center of the bottom, and it is raised, we see. But how can we find the position of the raised image? That we have done rather cleverly. We have actually have a rather graph paper pasted on the curved surface of the vertical curved surface of the cylinder, and the scale is moved up and down horizontally. A scale the students are used. A scale is moved up and down, and you see that time at a position when it is near the, almost at the same line, horizontal line, then the scale and the coin, I have taken a coin, will be in the same horizontal plane. That means as the graph paper is pasted on the wall, on the vertical cylindrical wall, and it actually is used as a scale, we can mark them, what is the position, the horizontal vertical position of the image, and we can find it easily from the, it's not very good experiment, but again, they can make some measurements and they can do it at home right now, no problem. I'm telling that whatever I'm telling the experience to be done. Yes, here is the Bernoulli's theorem, you see. I am not going to talk of that theorem. I am just, you can do the experience right now. In fact, when next day we are meeting, I shall request all of you to do all the experience what I have told in the meantime. Can do and enjoy. And till the results. Of course, I am not telling you to do the experiments on Curie point measurement or the measurement of this molecular electric dipole moment of water molecules. I am not, because they need something more. Not that experiments are very rather difficult, but you can do it at your labs only. So you see, water is taken in a plastic bottle of uniform cross section. A hole is pierced near its bottom. One can show that water level in the bottle moves downward with uniform deceleration. One can study kinematic relations and even find G using Bernoulli's theorem. I'm not going to tell the theory because that will take some time. You try it, and if necessary, you can discuss it. You see, the hole is pierced here, and the level is initial here. We can put one scale here. Again, I am very much favorite of using the graph paper sheet as the scale, which we can paste it on the curved surface of the cylindrical body, cylindrical cylinder, and that can be used as a scale. And you have got your mobile phone, and there is a stopwatch also, so we can find the position of the horizontal position of the horizontal water surface at different time. Draw the height from the hole. From the hole, you can draw the or you can measure the surface from here also. You can take origin at your convenience, and you will find that S equal to ut minus half ft square, and all these things are very easily visible because it is so accurate. It is actually uniformly it is decelerating uniformly. I must acknowledge this time that experiment was first performed by Professor Surajit Chakraborty of Maharaja Mohanjodana College, and I have borrowed this experiment from him. So this is a very nice experiment, and I think if you want to introduce the kinematics I am telling that whether S equal to ut minus half ft square, these things, I think students will learn many things after doing this experiment. They will learn how the acceleration has to be measured, how the graphs can be drawn, and so many things. So this is, and if you use Bernoulli's theorem, G can be measured. But I think only Professor Chakraborty could get it accurately. I am not getting it because you see the hole that is pierced to the plastic bottle is not uniform. Surface is very small, but that is not uniform, and that is playing havoc. It is not giving us the accurate result. We have not got, but only Dr. Chakraborty told me that yes, he has got the accurate results. That baby, but you can do it. I think this is a very, at least for studying kinematic relations in physics, it's a very good experiment. Thank you. I am going to the next experiments, Cartesian Diver, of which Anirban was talking of. So you see, I can. Right time I cannot show it to you. I shall later on. I shall show it because we will be again meeting you. So I think we can show it to you. So you see, what is the thing? What are the things? You see, this is the big bottle, big plastic bottle, and the small vertical that bottles. It is actually a homeopath's glass bottle, homeopath, not plastic bottle, because nowadays these homeopath doctors are using small plastic bottles. That will not be doing. So this plastic bottle is filled almost with half of water. You see, this experiment. You see, and you see, this is actually in this situation, it is in equilibrium position. that means it is floating. It is floating without going down or going up. That means the entire mass of the small cylinder is equal to the buoyant force it is experiencing this time. And you see that almost half of the bottle is filled with air and other half is filled with water. That is the situation here. And this is one situation if it is pressed, otherwise it is float here. If you see that much water is introduced here, so it has gone down. That is condition of flotation has been rather not respected. So it has gone down. Here condition of flotation has been respected. And here you see, it is when now, suppose it is in this situation. Here in this, you see that pressure is given. What will happen? You will see definitely that it is coming down. When you are giving some pressure, and you have seen here that air space has been rather decreased and water, some more water is there. So naturally, its weight is increased. Buoyant force almost remain the same because the entire small cylinder bottle is always within water. So naturally, buoyant force is the same always. But here the weight, because some water has rather entered the small glass, a small bottle. So its weight has increased and it is going down. So this is the situation. What will happen? I'm telling, as soon as you press the plastic surface of this big bottle, then what is happening? Because these two bottles, the small bottles and the larger bottles are connected, interconnected, because these small necks. So when you put pressure, according to Pascal's law, that pressure is communicated to everywhere. That pressure is communicated to everywhere. So naturally, when it presses the air there, the air is compressed. And when air is compressed, then some water actually enters the small bottle. So its weight increases and it goes down. Okay. Again, when it is released, then this is coming off. You see why it is coming up? Because as soon as you release, Pascal's law is not working in that way. So necessarily its pressure is much larger than it should be. So it explains its pressure within the smaller cylinder is much larger. So it expels the water inside water and it becomes lighter. So it moves off. So these things will happen, and these things happen actually is the property of the the submarine. By some means, by having some tanks, they are actually filling these tanks when it want to go inside the sea, and when it wants to float, then tanks are made empty, so it goes up. So that is the basic principles of submarine, working with submarine, and with its help we can do a lot of experiments. You see that we can show what is meant by Archimedes principle. We can show what are the floating conditions of flotation. We can show what is meant by Pascal's law. We can show what is meant by incompressibility of water, what is Boyle's law, and above all, we can again, if you have a graph paper pasted on the surface of the bigger bottle, we can find the kinematics. We can develop, we can really verify the kinematics relation. We can do many things with this simple bottle. And in fact, we have seen, in fact, we have done this experiment together with Anirban also, and we have seen that how the surfaces of the oils change. Suppose if you take some instead of water, if we take some oil, say mobile, then we shall see that when we're putting pressure, then the film surface is changing. So many things that is happening. Okay, so these are the experiments that can be done with Cartesian Diver. Oh, okay. Now we can have any discussion if you like that. Oh yes.
Thank you, sir.
No, one thing I'm telling you, because someone was talking of the surface tension. Yes, or madam was talking of surface tension. How can it be? You see, in this experiment, what will happen? You see, when the experiment is finished, you will see that level, just water level is not here. Water level is such, you see 2-3 millimeter above the hole here. Why is it so? Because of surface tension. Because of surface tension. Because you see, actually, water is coming. This is actually open. This surface is open. Okay, so you should have drawn the open surface. That means that the atmospheric pressure is there. So actually, the water is coming down, undoubtedly, no problem. But ultimately, when it is just near to this hole, then because if that a surface develops here, and that surface forbids further water to flow further. So naturally, the few millimeters above can be used to measure the surface tension. How are we really satisfied that this is due to surface tension? We have done the experiment with, you see, some water, soap solution water, or just putting some detergent powder in the, then you have seen that actually water level comes down at the level of the hole. That means, madam, you're telling that we can do the surface tension experiment also here also. In fact, that in the next spec experiments that I have shown here also, you see that Cartesian Diver, we can see if you take some oil instead of water inside the small bottle, that becomes some curve, they become some films are there. That is also due to surface tension. So when we are doing experiments with liquids, surface tension will inevitably appear. At least for demonstration. For measurement, I think that's a quite different issue.
So thank you, sir. Right now, I want to show something. Actually, the Cartesian Diver experiment was little tricky. So it will be better if Professor Samanta can show it afterwards.
We shall show afterwards. No problem.
Because the how to put the smaller bottle within the bigger bottle, how to fill the smaller bottle, there are lots of tricks involved in it. So I'll request you if Samanta sir can show it afterwards. So what I want to convey that during this period we have talked lot about the physics experiments, but those who are from biology or chemistry background, they may be thinking, what about us? Actually, we are not focusing on physics. We are focusing on how to develop low cost experiments and how it would work. So right now we have these things in our hand during this lockdown period. So we are able to show these things only, but we have lots of chemistry and biology experiments also, but we don't have in our hand to show it just right now. In future, if we get allowed to intermingle again, so that time we could show it. But I would request the teachers who are from biology or chemistry, the madam from Tamil Nadu was from chemistry. We have expert from chemistry also, but he could not join us due to some limitations of equipments. He has developed lots of experiments with chemistry, and he actually, what happens in classroom, we always say for a chemistry experiment we need these some large infrastructure, some these type of instruments, some key apparatus and all those things. But we can show, if we get chance, that using a very simple test tube, a pinch of chemical, we can show the production of hydrogen, production of oxygen very instantaneously, and that could be helpful in classroom situation, so that the student could understand the actual basic principle. Actually, we want to show, we want to make them understand the actual basic principles. And I would request the participants in next session that you please develop some experiments and show us during the session. And right now I am going to share the technical aspect, that how we could show a live experiment using our device to our audience. So first, you can log in with your using your mobile phone, and then put your mic on, and then go to the share, and in share you can get the screen share option that I'm going to show you. And after pressing the screen share, you can see here, your device will be on, and then put your camera uh, on, and that's how you can show whatever in front of you to the audience. And in this situation, you can perform in front of your camera and with your um, headset or mic, you can talk simultaneously during performance, or say someone to perform in the camera, inside in front of camera, and you can dictate the whole thing. In this way, you can share your live experiment with the audience. That is the easiest process. And another thing you can do, that is you could share the screen with audience, but there is a problem, because whenever you want you try to show video, try to share video screen, you need to our practical experience, we find that we need a very good laptop with a good configuration. Otherwise the video will be truncated, will be transmitted in a truncated form. It will have lots of glitches, so that is much more inconvenient. In that case, our mobile performs very well. In that case, you can share your screen with you can share your video with screen sharing of from your mobile phone. But there is a limitation in Zoom. When you are trying to share something, some videos from your mobile phone with the screen share option, you cannot share the audio. In that case you cannot share the audio, because Android system does not allow to share the audio. So there will be some tricks that we can use, that I will show you later, how we could play the audio and video simultaneously with the mobile phone, using just two mobile phones. That in that case we need two mobile phones, and I will show the tricks, and that will the technical aspects that you need to know when you are trying to perform something in front of your audience in live with the Zoom or something like that. So that is a crucial point I think we have to share with you, because whenever you are trying to mentor some program with on this digital platform, you have to know the small tricks that you can use, that you have to use to accommodate your program properly. So that's how you can share your experiments also in next session. And in that case, you may do another thing. If you want, you record your video with your mobile phone, your experiments, and send to us to our WhatsApp group. And in that case, I will try to show that video, to share that video with the audience. In that case, I will use the tricks that I am going to tell you later, that how to use the mobile phone and share the video along with audio. But right now we can do that. You just shoot your experiment and share with us in our WhatsApp group, and then I can show you on behalf of you. So that may be done. And further, in our further sessions ahead, we'll share all the tricks that we can impose to run the program properly in a seamless manner. So that is the thing I want to share. And right now, if you have something to tell, you can ask us. So the session is open to discuss right now. So please.
To show some video of the experience that we have shown, actually, that Cartesian Diver experiment and that flow of the liquid. Can we get some times, or it is open to discussion? Do you hear me?
Sir, would you like to show the experiment right now?
Yes, yes.
Okay,
Video,
sir.
not video, not experiment proper. Okay.
Okay, so please share.
Yes. this is the experiment, the last but one experiment. That is, you see, is the cylindrical bottle containing water. That scale has been prepared and hole is there. Okay. So it is when it is completely emptied, still the water will be at a level which is higher than the position of the hole. And from that difference, the distance height, we can find the surface tension. And in fact, quantitatively, I have not done in fact, but that can be done. But accuracy, I have not ascertained how much accuracy will be. So this is the one experiment that we have shown, PPT. You see the arrangement completely. Okay. Now let us move on to the next experiment. That is the Cartesian Diver. You see the bottle, the big bottle and the small bottle, then, and you see the motion also when it is compressed. And yes, another thing, you can show the total internal reflection also. If you observe it even from outside, it is clearly observed that as if it is the smaller bottle, the upper half of the smaller bottle is filled with mercury. You see, that is due to total internal reflection. So we can cover many things within this simple set. And so you can ask your students to do both these experiment. That is the flow of liquid through a hole at the bottom in a taken in a right circular cylinder, and this Cartesian diver. Okay, thank you. I shall share more experiments. At least as some of you have suggested to do some optics experiment, I am ready to do, no problem. Only thing I have to make certain arrangement that will take time. Okay, and in presenting my in my presentation, I got the support of Anirban Samanto and Saddam Khan from IIT TLC, and thanks also to them. Thank you again. If you have any questions, you can ask
Thank
me.
you, sir. We have few genius behind our screen like Anirban Samanto, Saddam Khan, Tonomoy Pal. So those are the people who are doing the things every day, and they are right now behind the screen, and you will be introduced step by step to them. They are very genius people. So they have supported Professor Samanto to do that. And right now, if you have any question, you can ask. So I think you don't have any question, right? Because we are not getting any response from others, from the participants.
Now, okay, then I shall expect something from you that we are giving this PPT to you. Necessarily, it will be actually you can go get it from that that is the YouTube, and go through it, and if possible, do the experiment. If you don't get the time, tell your students to do the experiments and discuss next time. And so I shall try to do some more experiments on electricity and light after on that day.
And I will share the PPT with you and the videos, whatever the Professor Samanto will give to me. So that will be shared with you. And another thing I want to share that in first phase, lots of participants took part and they showed their experiment they shared with us. So I would expect that similar things from you, and that will make the session more joyful. So please, Ranjit, sir.
Sir, I just want to ask the question to Samantha, sir. Yeah.
Yes.
Am I audible?
Yes, yes. Continue, please.
Sir, how we can determine the angular velocity of Earth by that experiment in which we were using sticks?
Yes, yes, yes. Because you see, you have performed the experiment at 10 o'clock in the morning, okay? And you find the angle theta, okay? And again, you do the experiment, you see at 12, you find the angle. Okay, I think how much this difference in angle divided by the time gives the angular velocity, okay? at least this is my supposition. You can think whether this is good or not, and you can think of. This is my idea. That is I'm telling. Okay, angular velocity.
Okay, thank you, sir.
Yes.
Thank you, sir.
Thank you, Mr. Ranjit Kumar. So anyone else?
Sir, from the Jordan's law, we know the height is inversely proportional to the radius. So if we take a narrow tube, narrow bottle, then we can find the height easily.
Yes,
and then
I think so.
Then we can get the surface tension easily.
Actually, initially the experiment was rather designed for the purpose of verification of the kinematic relations. Later on, we come to notice that surface tension can also be determined. So you can try this. We can. In fact, it will depend not on the. I think so. It will not depend on the radius of the cylinder, but I think it will depend on the radius of the hole. Okay. So I think so, but you can try both the ways. You can change the holes and see whether but measurement of radius is very tough job. Radius of hole, measurement of radius of hole is a very tough because it's very tiny, you see, few millimeters, is less than 1 millimeter like that. So that is a tough job, but if you can, it's fine. I can suggest you measuring. Suppose if you pass it using a needle, then and you rather measure the radius of the needle, that can help again. Okay.
Thank you, Manoranjan Bera. He will be one of the acting. He will be acting as one of the mentor in our Bengali session. He was a participant of our first phase, and he is associated with us from long time back. So these are some very dynamic people we had during this period during our first phase. So thank you again, Manoranjan Bera.
Thank you, sir. Thank you, sir.
But Manoranjan, again, if you put some detergent powder, there will be no difference. A level will come down to the center of the hole. Okay, that you can also.
But we know that if the impurities are present in water, the surface tension is changed. So can I get the same result?
With detergent, for different impurity, different results are there, you see. But with detergent, surface tension decreases very much. Suppose that it is very much it decreases. So you will practice it, notice no difference. Okay. But you have to do all these experiments and take the results and inform us also. Then we will be enriched from your observations. Okay.
Yes, sir. Yes, sir. Yes, sir.
So please, all of you, please do the experiments and see whether things that really can be used for academic purposes. So your observations will enrich us also. Thank you again.
Okay. So sir, come back again and.
Professor Ghosh is going to say something, I think. Professor Ghosh.
Nothing more to add at this stage. It's okay.
But I am seeing your name on the screen, as I'm telling you.
Excuse me, sir. Sir,
Yes.
I wanted to a little bit more about total internal reflection that you were talking in Cartesian Diver experiment.
Yes, you do the experiment and you will observe it. Because you see that in the small bottle, the surface above the water is empty. Empty means contains water, you see. But as you see, that light is coming from water to the glass and again to air. So there is from where it is coming from glass to air, because the small cylinder is made of glass, then there is a possibility that if the angle of incidence is greater than the critical angle, then there will be there will be total internal reflection, and it is happening. So you please collect the things, that is the that big bottle, the small homeopathy bottle, and you please keep it in mind, it should be made of glass, not plastic. Then you will do it. You'll be able to do it. Because it's very simple experiment.
Okay, sir.
Hello. I am audible now. Am I audible? Hello, Professor Samanto. Can you hear me?
Yes, yes, why not? I am hearing, no problem.
Okay. Actually, I got disconnected for some time, so that's why.
No, no, I am always. Okay.
So,
If there is nothing to transact, then we can stop here right now. Is it so?
So if no query is there, then we can end the meeting right now with your due permission. So can we?
Yes, yes.
Okay. Thank you, everybody. Thank you for being with us.
Thank you,
And,
everyone, sir.
and we will come back again at today 5 p.m. In that session, we will actually that session was meant for argument-driven inquiry, but but we have decided that today's evening session, Professor Plavan Kumar Bhaumik will share with you the with you about the detail of digital learning platform and how we can use it. So that will be discussed on evening session, and that is going to be a very interesting session, and it was in the first phase also. So I will request you, please come back again at sharp 5 p.m. Until then, goodbye and thank you all.
Thank you, sir.
Thank you all, sir. Thank you.
Thank you very much.
Thank you all again.